Good afternoon. I'm Jasmin Liao, and I'm presenting my research project, Artificial Intelligence Designed for Attendance. It is an intelligence video-based application to automate student attendance checking using computer vision and artificial intelligence. Engaging online students is a challenge for many teachers. While I was a student, I saw teachers struggling to take attendance due to the number of students leaving their class after attendance. Students would be held responsible for their work using facial recognition technology. To simplify the process of applying absences to students in each class, this paper proposes an application that would allow teachers to stay on top of their work. We applied our software to test students in the classroom and use various libraries/CSS styles to create a classroom that is easy for both the student and the teacher to read. Our designs are built upon OpenCV and PIL, which are used as geometric classifiers to determine if the student is present. We used several phases to see if the algorithm was suitable for the program, and we were able to create a classroom that is safe, engaging, and easy to use. So what is our method? We follow the same line of research of Google Classroom. We were mainly inspired to create a classroom that was more easily accessible like Google Classrooms. And we have two roles in our app, which is the administrator and the student. And the teacher position contains special admin roles and is able to create classrooms and send invitations for the students to join theirs. Students are able to access the classroom once given the password for the classroom. And from there, teachers are able to see whether the student enters the app or the classroom. And they usually enter the classroom using a TOTP generator. So they make sure that the students have double TOTP like passwords, and make sure no strangers come in from using two different codes. And teachers and students will be able to log in using this TOTP app that gives them the code. Our process implementation. We implemented each component in different platforms. Google Colab is applied to design the basic functionality of facial recognition. We use Google Drive to store the pictures and create a folder path to store the photos. And we use libraries such as PIL that allows users to open, manipulate, and save images in Python. Initially, our challenges were getting the facial recognition to work in the first place. There were several algorithms that we were testing from, and due to the inability of the program to recognize faces in live video, the program would often result in errors. So we solved this problem by using a visual point recognizer program called OpenCV to map out the face encodings. And we used two separate databases to connect them. Sorry. So the methodology of our whole system basically gathers the data from the screenshot using library, and then the photo is saved to a data set, and then the processing through a geometric recognizer program called OpenCV. By using those two sets of the known and unknown data set, compare the two and run samples, and it tests each time to make sure and ask each student whether they ask each teacher to check whether the student is actually the student. And over time, it will gradually recognize it and won't need to ask for it anymore. I believe the tolerance determines the distance between faces to consider the faces as a match, and returns a true or a false if the tolerance is lower. In the event that they recognize a face as belonging to the student, does the computer record its attendance? And this is the overview of the figure in one. I conducted research with my professor on how our program works. several tests were made on the project to ensure that the facial recognition would work. Matching celebrity faces with various photos was one of the experiments that we practiced. And we made sure that they would correlate with the other different pictures in different forms, like side profiles and front face and all of those photos. My hope is that I'll be able to further develop this project in terms of creating more video-based application. Currently, our program does not work in video because of the lack of time we had in this project. Our website tested the teacher's abilities as well as the students' perspectives. So here is our I think these are the different admin controls. It could create classrooms, and then it could upload the file of the classroom or the Zoom meeting, and it'll register their faces in there. It could be just like a classroom photo that they could upload, and it automatically recognizes the student, and it would just record in each class, for example, hello world, and then it would have their student ID and their grade and their name. My solution solves the problem by addressing classroom management to upload the picture of the classroom to determine who is currently inside the classroom. We sample different accounts to check whether the students have been recognized in the program and whether they had difficult logging into a new classroom. The results show that the students were able to access and be added to the classroom based on feedback I received. Classroom should have limits on the students' facial test, and which I agree and hope to address later. And we took related studies such as CAR's facial recognition algorithm, which described a method that discussed the broad range of methods used for face recognition and attempts to discuss their advantages and disadvantages. Initially, we present the basics of facial recognition technology, its standard workflow and background, and the potential applications. And also the same for Amazon's web services and how AI is building a greater impact on how the world functions today. As a result of the pandemic, I was inspired to develop an application assisting teachers with their attendance. It was through this project that I learned how to incorporate machine learning with its web development platforms like wereable, Firebase, and Colab, made it possible for me to create an environment for my application. The project turned out to be a success. However, we are still developing the program so we could expand on machine learning and the limits to classroom safety. Previous experiments from the algorithm proved to be efficient as it identified the person from test 15 people within a picture. And the effectiveness of this project is mostly limited to the classrooms page, the TFTP generator. Currently, we are a little bit behind on trying to create a classroom that's more, it could add more students. And it's really difficult for us to get a picture of everybody in the classroom. So we're trying to make it so it's video based. And I want to improve the accessibility through web roots and web page functionality and the sourcing of the project. So thank you so much. Do you guys have any questions?